All right. I think I'm up and streaming. Yeah, still getting the hang of these tools. Uh, Thank you for joining me today. If you're watching, second, I just want to pull up one little thing, little chat stream in case people want to start leaving comments or anything. Okay, now let's get going. All right. Thank you for joining me. My name is Jake Broom. I am the founder and CEO of Evented. Before we get going here, I want to give a little shout out to my wife, Robin, of 20 years. She designed this kick ass logo, and she's kept this belly filled for 20 years and dealt with all my shenanigans. So, thank you. Today, we are here to talk about fact. That little guy right there, that little turtle. I was a product of the 80s and 90s. A lot of turtles in my life. The mutant ninjas, Bowser, and all the Koopalings. I just always liked turtles, so that's kind of why I chose a turtle as a logo. Let's dive in. Let's just get into it. Here we go. If you're interested, you can find the source code out on GitHub at github/evented/fact. Feel free to give it a star, give it a pull request, play around, have fun. You can also find it if you're already part of the Beam, Elixir, Erlang, Gleam ecosystem. You can find the package out here on HexPM. Fact, currently at version 0.1.2. And that will continue to grow. I can promise you that. All right, let's hide that. Let's just dive right in. First things first, we're gonna need a new Elixir project. So let's do that by doing mix new. Let's call it demo 1. And we'll give it a supervisor. Great. And let's just dive into that project folder. Quit screen. So we're going to need to include the fact library as a dependency. And we do that by editing mix.exs. That's kind of like your package JSON if you're familiar with Node.js. So let's just do that. Oh, I don't have them. Let's do VI. Okay. Go down here into the file, down here to the depths. We'll insert right there. And we'll do fact at 0.1.2. Close that off. Hit enter. We'll just put that over there. Great. And now let's see here. No, that's not how I do it. WQ. I think that'll do it. Yeah, there we go. Let's clear that. Okay. Now we have that. Let's also then run mix deps get to pull that down. So you can see we pull down fact. It has a few dependencies here. It's dependent on Phoenix PubSub, the UUID Perl package, and QuickRand. I don't remember that one. That must be a Phoenix PubSub must that, or maybe UUID. Anyway, that is that. Next thing, if we go, we can, now that we have the fact library, we can create a new fact database. And the way we do that is by using a mix task called fact.create. Mix fact create, and we're gonna want to put that. Let's put that in the temp db1 folder. Great. It compiled all the dependencies, and you can see here that it ran the task and created a database here. It produces a unique identifier for the database. That's our name and the path that it is stored in. Gives us a little bit of tips on how to get started. So let's do that next. And then also, if you want to go read the docs, there's a link here for that. If you want to learn more about event sourcing, here's a link. Right click, open a hyperlink. There we go. There you go. It takes you out to Martin Dielger's Understanding Event Sourcing out on LeanPub. Fantastic book. Highly recommend reading it. I have my copy. Oh, yeah, it's right here. Here you go. Love this book. Anyway. And if you want to get better at designing event source systems, I would highly recommend using event modeling. And please go out to eventmodeling.org. There's a lot of great resources. You can see that they're big fans of this book as well. A lot of other great resources, though, blogs. There's a great community. Hop on Discord and join that. You are. Okay, but let's get back to it. Okay, so let's just open up the little REPL here with IEX. Okay, we've created our database. It's stored here at tempdb1. And let's actually open it up, see what's inside. So say okay, db, back.open, tempdb1. All right, so what this is doing, it hands us back in a result tuple. Everything's okay, hands us back to the database ID. That database ID is kind of like the handle to this specific database, and all of the Elixir processes that are running. We kind of pass it into almost every function so that it can find the right database context and read files from the file system from the correct location. So for instance, if we want to read all of the events that are currently in the database, we can do that next. Read, there we're passing in the database handle. It's this value here is stored in this variable if you're unfamiliar with Elixir. And then we'll say read from the all source. There we go. And it dumped out the event. When you create a event database, it actually records that as the first event in the event store. You can see here that it is I call it the Genesis event, but in reality, it's a module, a structure in Elixir called fact Genesis event database created version 1. Well, let's explore it. It's got a lot of stuff in it. In the event data, it records information and configuration about all of the different configurable points of the library. Like for instance, here we got the index file encoder that uses a delimited strategy, and the delimiter is a line feed. A lot of these there's not a lot of options to them, or they're already pre-defaulted, so they're not showing here. They just take the defaults of what is in the system. Like the record file names here are set to event ID, so that means the files written to the file system, the record files are going to be named according to their corresponding event ID. dig in a little bit more here. We have like checkpoint decoders and encoders. It stores the version. So this database was created using fact 01.2. It stores the Elixir version just in case I need to deal with compatibility issues in the future. I know I'm behind the times using 118 and not 19. Here we go, the ledger file reader. It's a fixed length reader. It reads length of 32 with 1 character padding. So all of these configurations here are stored as an event, and when the system is brought up or bootstrapped, it reads this event, gets all this configuration, configures the system, brings up all the processes so that it can, everything is working as stated in that initial mix fact create event. Let's see here. It stores the database ID. Stores the OTP version, OS version, the ERTS version, all of that's for future compatibility. The event IDs, you can see here, using UUID, version 4, locks, ledger file, comes up with the random ID. I believe this is the same ID as this. This one's just base 16 encoded. This one's base 32 encoded. I don't remember if those are the same or if it's completely different though. Anyway, you can see here that it is stored as event 1 in the database. And this is just a Unix timestamp of when it was written. And I believe it's Unix in microseconds. That's that. Cool. Next up, let's see. Well, we have an event store. Probably let's create a first simple event. And to do that, it's pretty simple. We can just append. So we'll do fact append. That's in the database handle. And we'll write an event structure here. Something simple. This is going to look a lot like JSON, but it's an Elixir structure. Really, the only difference here is a few less quotes around the actually, in JSON, you don't need the quotes around the keys, but basically the same, except a little percent symbol in front of them. Let's add the classic hello world here. Okay. And boom. So we appended a new greeted event. It is has a little bit of data here, message hello world, and you can see it returned us a result tuple. Everything was okay, and it just appended event record 2 into the database. So now we can read that back again with fact read. Let's just read all. We once again have our Genesis event read first, but then it also dumped out here our little greeted event, store position 2, and there's our message. Fantastic. But what if we don't want to read that first event? What we can do is actually set the position we want to start reading at. So we can pull this up and say, I want to start reading at position 1. I'm saying position 1 because it's exclusive, so it's going to basically move its cursor just past first event and then read going forward from there. So, boom. Doing that, we'll get just that second greeted event. Let's open another terminal here and go into demo1 directory. Oops, what? Nope. We stored this in temp db1. So let's go there and let's look at this a little bit. So here's our database out on the file system. You can see a few things here. We got a lock sock file, we got a lock file, we got a ledger file, we have a get ignore file. Added that just because I was doing a lot of testing in my code repo and I didn't want all the events and indices and all these things being accidentally committed to source control, pushed up to GitHub. So I just throw that in there in case people are doing something similar. So you can see here that we have an events folder. Let's explore that. So let's do there. We have 2 files in here. Let's side by side. You remember earlier when we looked up here in the database, the Genesis event under event record name. Where is record name? There it is. Record name set to event ID. So when we go down here and look at the event ID for the second event, 5AEA, you'll notice here there's a file named 5AEA. And if we were to dump that out with a tool such as JQ, and we would see, hey, there we go. It's just basically a JSON. That's all it is. That's a JSON. Here's the in-memory Elixir structure. 1 for 1. Yeah, so clear that out. Let's show those files again. So locksock, what's that file all about? Well, here, I'll show you. So we currently have db1 running in this console. This is actually running processes that are running inside of a Beam VM. If I were to open up a second VM, say in this console, I'm in the data folder. Let's move back here. If I start a second VM, I don't have any sort of gossip protocol or anything to ensure multiple distinct processes can communicate at this point in time. Right now it's kind of single VM. So don't want data to get corrupted. So if you ran multiple processes connected to the same database, they would have the potential to, like, some of the bookkeeping state within the database wouldn't be able to be maintained properly, ultimately causing data corruption. So to prevent that, if from this other VM I try to open temp db1, you'll see you'll get an error. This database is locked by basically this process over at this time, running on this Beam node, which is running out of this OS process and this Beam process or Erlang process. This is basically the process ID. So anyway, you can't do that. So that socket file is there to say, hey, when a database is started up, it creates this socket, Unix socket, and it's the only, basically acts as a mutex. So that's why that is there. Now, if I'm in the same VM, though, I can go ahead and open the database again. It's just going to return me that same handle. It's not actually making two connections or anything like that. It's just it's really just caching the handle and returning it since it's already open. Great. So that way. So we have two events. There's some other stuff I'd like to explore. If you know me well, there's a few things I really like in life, like beer, like pizza, and I love going to rock concerts. And I wanted to have some data to play around with today. So last night I spent some time building up a little Elixir module here that we can load. It has some information about concerts that I've been to. So let's load that up here. Here in concerts EXS. Let's see if that'll load. Yep, there we go. Concerts. And here's a few of the different, these are just methods that will return us a set of events that we can then play around with. So why don't we go ahead and grab the Foo Fighters. We'll store that in a variable called events. You can see here, these are just a bunch of events. Went to this show, Providence Park in Portland. These were the bands playing. Foo Fighters, Alex G, and the Pretenders. Here's the set list, all the songs that were played by the Foo Fighters. I didn't collect the set lists for Alex G or the Pretenders. But anyway, so now why don't we append that to a stream? Before we just appended to the ledger, not to a stream specifically. So let's append to a stream this time. And say BB event. And I already tagged this as concert 3. So let's just add it to the stream. Concert 3. Boom. Done. So this just wrote a whole bunch of events. I think we already had 2, so what was that? 23 events just got written to the event store. And let's read them. So once again, let's do a fact read. But I don't really want to dump all 25 events. So let's start actually at a position in 22. Here we go. So you can see here, position 22. Okay. All right. So we appended 25 events to the stream. So you'll notice here that this has a store position of 27 and a stream position of 25 for Everlong. Fantastic song. The acoustic version. I love the acoustic version of that song. Bear with me one second. All right, anyway. So as I was saying here, we just read from the all stream from position 20. So if we go up to the top here, yep. We read from position 22, right? So you can see the first event here is store position 23, 24, 25, it grows, but these are not in line with the stream position. That is a different sequence number. What I really wanted to do here is say, in fact, I want to read not from the all stream, but from a stream named concert 3. This is changing the event source from the ledger or the all stream or the global stream to the specific concert 3 stream. And once again, we're going to read that from position 22. But really what I want is here just these last 3 events. Let's go ahead and do that. And there we go. That's more like it. So we can see they played ended the show with Best of You, The Teacher, and Everlong. What else? What's something else that we can do while we're reading? We might want to read the stream backwards. Let's do that. Let's say direction is backward. We do that, we get nothing. And there's a really good reason for that. All reads are defaulted to read from the start position. Start position is the position before event number 1. So if we're reading backwards, what we want to do is actually set the position to the end of the stream. There we go. So now we have these listed, and if we look here, rolling back up to the top, our first event in the stream was at position 25, and it is decreasing. 24, 23, 22, 21. So we are reading backwards. Now, we can also read backwards from a specific position. So let's say I want to read backwards from position 10. But I only want to read 3 events, so we can specify the count property here. Boom. And you'll notice we have 3 events returned. 10, 9, and 8. When we're reading backwards, the first event is inclusive, unlike when we're reading forwards, where the position that we defined is exclusive. Something to remember. We got that, we got that. What else can we do here? We can add some more events. Let's add a few more events. Let's go back to concerts. And let's add the Green Day concert. Okay, so let's do fact, append. Let's store these in events first. Okay, that says it's concert 11. So let's just keep going with that. Let's do fact, append stream. And we'll put this in concert 11. Okay. A whole bunch more. That one actually wrote 38 events. Green Day songs are short. They play a whole lot more. Yeah. So now we have that. Let's add some more. Let's go back to concerts here. How about Weezer in 2023? Okay, great. A bunch more events here. Concert 8. Let's do that. Let's end stream into concert 8. So let's grab another Weezer event as well. We're at it. So events equals concerts. Just did 2023. Let's do 2019 as well. Okay, and that seems to be concert 12. So let's just do that. There we go. Now we got a whole bunch of events. Let's look at. Go back to the file. There we go. We're in tempdb1. LSLA. There we go. We can still, we don't have much here at the root, but if we explore events, whole bunch of events now written. Okay. One thing. Let's also take a look at the indexes. I haven't really talked about that. I've been posting about indexes all week. If you've seen any of my little infographics, I've been kind of explaining how evented indexes and a variety of, not evented, in fact, indexes things in a variety of different ways. So let's kind of look, before we dig into actually like querying with event querying or looking at the indexes in the code, let's kind of see how it's laid things out already. So let's explore the indices folder. Isn't it called that? Oh, not backslash. Let's see what's in the indices folder. And we have a few more folders it sees. We have a folder for each one of the indexers that is running in the system. You can see we have an event stream indexer, event streams, event stream category, event streams by category, event tags, and event type. I think over the week I've posted about tags, types, stream. I haven't really touched on event stream, streams, or streams categories yet, but we'll get into it. So let's first look at event type. What's in there? We can see a few things. So for every different type of event that we've appended into the system, there is a file, a Genesis event that's stored there. There's our first greeted event. We have concert attended events, and we have song played events. Now, if we look at concert attended, let's just dump that up to the screen here. Let's go indices, event type, concert attended. That is just a file containing a list of event IDs. These are the event IDs that we find back in that events folder. And this is just the order that the concert attended events have been added to the system. So yeah, it looks like we added 4. We should probably have just a 1 in the greeted. We only added 1 of those. So that's the event for greeted. So what I could do here is I could copy that, or I can say, let's do JQ again, events, and let's grab this. There, great. There we go. That is our Hello World event. Similarly, I could do that with any one of these concert attended events. I think the third one was a Weezer concert. So let's do that. Let's go like that. There we go. And it is. This was the Weezer concert at the Bend Hayden Homes Amphitheater for the Indie Rock Road Trip Tour. That was a good one. That was a really good show. Went there with my daughter. Ton of fun. And my buddy Casey. Let's see. Weezer played, Spoon played, and White Reaper played. It's good memory. All right, so that was the event type indexer. Let's see what else we got in there. Let's pop that open again. Indices, backslash indices. Okay, look at event types. Now let's look at event tags. If you've noticed here in all these events we've been appending, we've also been including tags like concert 12, band, Weezer. So let's take a peek at what's in the event tags folder. And there we go. We added 4 concerts, and each of those has its own specific tag. We also have the tag, the special system tag that was included on the Genesis event. And we also have tag for each one of the bands that was playing at these concerts. And just like the event types indexes files, these are just files that contain a list of event IDs. I don't have songs added for a lot of these bands like Spoon, but I did include that tag as part of the concert attended event, so they should have at least be related to one event. So let's take a look at that. So let's look at event tag band Spoon. Oop, cat that. There we go. That's the one event. Once again, we could do a JQ. And there we go. Oh, yeah. Same concert. Cool. So that is tags. Let's go back up here. Indices, tags. We have streams. Each one of these concerts we added to a stream. So similarly, we should be expecting. I think we added 4 concerts, so there should be a index file each one of those streams. So let's take a peek at that. And there are concert 3, 8, 11, and 12. And each of these contains the ordered list of all those event IDs for each of those concerts that we have. You've noticed here, I haven't mentioned this yet, but each of these index files also maintains a checkpoint file. And as you append events into the system, the indexers are notified that events have been appended. And then they will go check those events to see if they need to be indexed by said indexer. And the checkpoint file, if we take a look at that, is super simple. It just, yeah, you can see here 112. It is the store position, event store position of what has been processed by the indexer. So the event stream indexer processed all 112 events. It does that just so like when you start up the system again, it knows, hey, I've already done the first 112. I can just pick up where I left off. You go back in time and try and re-index things that I've already. Go back again. That was event streams. So we've done tags, types, and streams. If you're familiar with Current or the event store, formerly known as Event Store, and worked with its built-in projection system, they had these projections that would allow you to create streams of data based on like even how to know how to say that. It basically it had this concept of built-in projections, and it had a few of these like the category projection, the streams projection, and the streams by category projection. I'm not implementing it in the same fashion. These are just indexers, which technically projections, but inside the event stored database, they used a concept called link events, which would basically be like event records that are written, but they're a reference to another event in history. I don't have that in fact. It actually introduces a thing called write amplification, and I'm not sure that I want to introduce that here, because when you append an event, it would then the inline projections would run and potentially then create additional events in the event store, amplifying the number of writes with those link events. So anyway, I have the same concepts here, but they're just indexers. Yeah, so let's look at one of these, like streams by category. What or stream category? Let's just take a quick peek at that. Stream category indices. Let's see what's in there. Oh, it's got one concert. You'll notice here, a category, stream category is essentially the first portion of a stream name before that first hyphen. That's configurable in those mix options, but by default, it's everything up to the first hyphen, first dash. So what this is going to do is index all events by all streams that start with the word concert. We look inside that, or we counted, let's say, or count. Let's try it. Maybe it's, I'm getting mixed up between Linux and PowerShell now. Indices, stream, category, concert. No, count. Oh yeah, it's word count, WC. Okay, 110. So there's 110 events in concert category. So that's going to record every one of those concert events or every one of those events that we've added to any of the concert streams. So if you needed to build some sort of structural model based on the history of every event related to concerts, this is one way you could basically find that set events to process. And that's that. Here, hey, somewhere. Okay. So that's that. That was that was stream category. So what else do we got here? We have event streams. Event streams, that's an interesting one. I like it. The special indexer that anytime you append to a stream in the database, it will just record the very first, or just index the very first event of every single stream. So the result of that is get an index that has essentially just a list of all the streams. So if you needed to know every stream that's in your system, you could use the event streams index. Let's take a peek at that. And if we look at that here, there's just a file called index. Because this indexer, unlike other ones, kind of aggregates or reduces everything down into just one index file. And that index file contains the first event of every single stream. So if we look at what's inside of it, we're going to see we created 4 concerts streams, 4 concert streams. So there is one entry for each one of those streams. So I bet if we did the little JQ thing here on events, copy that, JQ events, boom, you can see here, yeah, this is a concert attended event. It is the first event in the stream. We did it with another one. Grab this third, 4th one here. Again, you'll see is stream 12, but it's once again the first stream or the first event in the stream. So this is just a list of every single stream in your system. Neat. I think we have one more index to go off of. And that is event streams by category. This is really a hybrid of the event stream category indexer and the event streams indexer. So it's still going to break everything down by stream. And then, so we'll have like an index file for all of the concerts. And within that concert index, it's going to break down and only show the first event of every concert stream. So right now, these are essentially the same. We didn't add a different kind of stream, but let's go ahead and make a new stream, just for the heck of it. Let's append. Let's just go fast. Let's do a foo event, and we'll add that to I don't know, the foo one stream. Great. Okay, so now we have 2 different stream categories. We have concerts and we have foos. So if I look here at the event streams by category, what am I doing wrong here? Indices, event, event streams by category. There we go. Oh, there we go. We have a foo index and a concert index. A foo index, we just created one event. It should have the same event ID of this. So let's look what's inside that. And you're right, it has one event because we have one foo stream. Let's just verify here. There we go. Foo stream 1. We didn't even add data. No. That's another thing. You don't have to have data. All you need for an event, in fact, is a type. Forgot to mention that earlier. Similarly, we can look at the concerts here, and it's going to be similar to that all of the streams indexer. What am I doing wrong here? Indices. Oh, it's a file. And it's concert, not concerts. There we go. So there's our 4 concerts. But if we went and look back at our event streams index file now, we would have the 4 concerts plus the foo stream. And there we go. There's that foo stream. See, same when we look at the foo category. Okay, so we've been playing around in the file system a bunch. You can also query all of these things using an index source inside Fact. And wow, I've been talking already for nearly an hour. Woo-wee. So, not append. We want to read, and I'm actually not really all that happy with this syntax right now. So there's going to be changes here in the future. In order to read directly from an index, what you have to do is use a tuple with the first element being index, and then you have to give it the indexer ID. Indexer ID is the module name, so I have to do something like fact event streams indexer, and then you have to also provide the index key. Many of the indexers don't have a specific index key. We'll jump into data indexers. Maybe I have to do that next week. So it's just nil as the second element of the tuple. But then we also need to specify the index file. So event streams and indexer just had one, and it was called index. And we can read that. So there we go. You can see, just like we were exploring earlier, this is just going to show you the first event of every single stream. So we got first event of concert 3, first event of concert 11, 8, concert 12, and foo. Likewise, we could do event tags indexer. And let's say we wanted to see all the events tagged with band Weezer. It's going to be long. It is. So, wow. Let's read a subset of that. Just like reading from the all stream, reading from the specific stream, you can always set the position. So let's read from the end and read backwards. And let's just read 3 events. So there we go. And then that's reading directly from the event tags indexer. But that, like I was saying, that's not really, I feel like it's not really ergonomic to read directly from indexes. There's another concept we have here called event queries, and this is in support of dynamic consistency boundaries. There's been a lot of posts about it this week. Check out dcb.events if you really want to dig into dynamic consistency boundaries. But in support of those, we can also do read via a query. The way we do that, to make it simple here, we're going to quickly import fact query item. And that has a few helper methods on it to build queries. You can query things by tag and event type. You can also query things by data. The DCB spec defines that query has to have types tags. I've tacked on data. But let's just dive in a little bit here earlier. So we wanted earlier to see all of the events tagged with band Weezer. To do that via a query, we would do something like this. Let's say fact read, and we want to read from a query. We want to say tags And this tags function is actually imported from this fact query item module. We'd say band Weezer, just like that. And that creates a query. And once again, we're going to want to just read a few of these events. So count, let's read the first 3. Go. So what you'll notice here on these events are they all are tagged with Weezer. So, but we can do more complex things with queries. So let's make a complex query. Let's store it in a variable called CQ for complex query, and we'll create a event or a query that is for tags for the band Weezer. But we're going to pipe this into another query helper called types. We only want to find the event types where it's concert attended and the tags in the event is tagged with band Weezer. Okay, so now you can see we have this little structure here. It's storing the fact that we want these tags, band Weezer, and types, concert attended. So we can go back and do a fact read here, and let's just do a query and pass in that CQ flex query, and let's just read everything. Boom, there we go. We have 2. We have this one, and we got this one. So that's that. But I also mentioned that we could do data queries. Now, I would recommend, like, as you're designing your system, knowing every way that you want to query, possibly, and set up all your queries using tags or types. But sometimes we miss things and we need a quick way, or just you might just want to explore data in a different way without creating the tags. And you can do that via a data query. So what's neat is, if you noticed earlier in the file system, we had no event data indexers. But what we can do, and I hope this works, why don't we say, let's index everything by city. So let's go back to the complex query and let's tack on data to that. We'll say city Portland. Okay, so now we have a query for, I want to know where concert attended band, where the band was Weezer and the city was Portland. So let's query for that. Uh-oh. Valid index module. This is so silly. When you're using IEX, sometimes it doesn't load all your modules. This doesn't happen in production because everything gets compiled and preloaded. So ensure to loaded fact event data indexer. Okay, now that indexer module is loaded, let's try this again. Boom, there we go. Sweet. So you can see now it filtered that query filtered the set even further. We have just the single concert where the city was Portland, the band was Weezer, the event type was concert attended. Ooh. But what happened out on the file system? We go back out and look at the indices folder. Let's see, we now have an event data directory. So let's look at event data. Oh, there's a folder under that named city. So if we look under the city folder, we have two files, a Bend and a Portland file. So what it did was just in time as we submitted the query, it realized it needed to start up the event data indexer specifically for cities, any events with city keys in them or fields, and it went to work and indexed it. We look inside Portland. I know, I think 3 out of those 4 that we added earlier were all in Portland, so I would expect we look inside Portland here, we'll have 3 events. And we do. And there was 1 concert in Bend, so if we look in Bend, there's 1. Great. So that is really an intro into Fact. We kind of covered creating a database, appending events, and querying events in all the different ways that you can via the all stream, via specific streams, via indexes, and also via queries. But before I go, I just want to show, like earlier when we were playing around with querying by index, I mentioned that many of the indexers don't have a key associated with them, so we just fill in nil. For the event data indexers, we actually do require a key, and in the example we just did, that key would have been city. So if I wanted to read all the events that have been indexed by the event data indexer on the field city and say the index file Bend, that's how we would do that. There we go. Already been at this for about an hour, and I don't want to consume everybody's time too much. This should be posted to YouTube. So if you missed out, you can watch it later. But if you're not here, you're not even hearing this message. And I think next week, maybe I'll do another one of these and jump into catch-up subscriptions. It's a lot like reading, but rather than you requesting the events to be read, you subscribe, and in fact, we'll push events to an Elixir process so it can handle them and work in a more reactive fashion. And with that, just want to say happy Friday, everybody. Thanks for joining me. Please keep following, supporting. Give me that star on GitHub if you dig this stuff. If you don't, well, that's cool too. Yeah, everybody have a great Friday. Take care.